Okay, we're going to talk a little bit about perfect squares and perfect square roots. So a perfect square, is when I take a number and multiply it by itself, or they call it squaring a number. So if I have 4, squaring means it has an exponent of 2. So when they're talking about this, that's referring to this. Okay, so if I have 4 to the second power, that means I take 4 and multiply it by itself twice. So 4 times 4 is going to be 16. Now, we have talked about Desmos a little bit. So let me pull my Desmos up for a second, just so you can see this. So if I had 4 squared, I would hit 4. And then if you look on the left-hand side, you'll see a column that has X and Y. And you look at the column next to Y, it has A to the second power. If you hit that button, that automatically makes it square. Okay? If you had a power or an exponent that wasn't 2, the button next to the A to the second is A to the B, so A with an exponent of B. If you hit that, you can put in any single exponent that you want, no matter if it's 2 or something else. So this might be something that you might want to use Desmos on if you don't have a good calculator at home. Okay, so again, you can either, if you have a device of your own, there's an app called Desmos, that's what I'm using, or you can go to www.desmos.com and there's a free one, and you can just have the tab open while you have your work open and be able to work through it. Okay, so you may see a lot of problems that look like this, and they are strictly just putting them in your calculator and calculating them. So on the first one, it has like 11 squared. That means it's 11 times 11, which is 121. So going through these, you should be able to put any of them that you have into your calculator, either by using the exponents like this, or if you don't and you just want to do 11 times 11 because there are 2 as that exponent, that means it multiplies 11 by itself twice. That's certainly one that you could do. Okay, now the opposite of that is square roots. So a perfect square root, first of all, it uses a square root symbol. So that means it has to have a symbol that looks like this. Okay, and you look at the number that's underneath it, and you want to figure out that number underneath. What number times itself would give you that? So we just talked a little while ago about how to be able to solve, something that this 4 to the second ended up being 16. So that means 16 is 4 times 4. So that's kind of the idea that we use here. So if you know that it's the square root of 16, that means you want to find what number times itself gives you that one underneath, and the square root is just one of them. Okay, now we were just talking about using Desmos, so let me pull that up again. The nice thing about Desmos is it has a square root. So if you look towards the very bottom row, there is a square root symbol. So if I put 16 there, it'll tell me what it is. Now, there are times that you might do a number and you won't get a whole number. See, like if I do the square root of 11, there are no 2 whole numbers that multiply together to give you 11, so it gives you a decimal. So that means it's kind of what they call it to be irrational. That means it's a number where the decimal goes on and on forever and doesn't stop on its own or repeat or any of that. Okay, so whenever you see these, you have 2 choices then. Like the first one's the square root of 256. So if you're not sure what number times itself gives you 256, then if you go back to Desmos and do your square root of 256, might help forget the whole number there, huh, guys? There we go. You could say it's 16 times 16. Now, when we work together, we are going to make a list of perfect squares, so it might help you a little bit to be able to work backwards, but just kind of keep that in mind. I think most of the ones you're going to see, at least at the very beginning, are going to be ones that are going to give you whole number answers. But if you happen to get one, like we said, that square root of 11 gave you kind of an ugly looking decimal. So if you have something like that, it was one that was like 3.3166247, and it would keep going. This is considered to be irrational. Now, when you talk about irrational numbers, kind of think about your own life. So, irrational people are ones that we can't predict what they're going to do typically. So, an irrational number is the same thing. We can't predict what it's going to do because it doesn't end on its own and it doesn't repeat. Like it doesn't go 0.55555 and keep going forever. So, all the rest of the time, if you're getting a whole number like these, those whole numbers are rational because just like rational people, we can predict what they're going to do. Okay, we'll talk about a few more next time.